Okay, guys, here we go. We're looking at number 2. This is in 2.6.2, number 2. A lot of 2's in there. All right. So this is in the workbook. I actually have the pages here if you need to find it. I think this might be right for your version. Okay, here we go. Now, remember, we're comparing these, right? The things that are in common or that we can measure for both of them are the y-intercepts for A and B, given here, A and B, and also the slope, the rate of change. The rate of change is how we're showing slope, or how we're speaking about slope in this case, the rate of change. So here's the thing. We need to find the rate of change and the y-intercept for A and B over this interval, 0, 5, 0, 5. So if I'm only able to look at it from 0 to 5, remember this is just the lower and the upper. The lower and the upper limits for our x values. Remember the interval, this is just saying, okay, if I have a graph right here, I have a graph right here. This is saying since the interval is 0, 5, oops, I'm going from 0 to 1, 2, 3, 4, 5. Right? And what I know is we want to see what is going on with the graph between 0 and 5 for x. The interval just says, hey, where are you going to look? Where are you going to look? Look here. Look here. Don't look over here. That's outside of our limit. If you've done this homework, you don't have to copy it. If there's something I say that's different, you can copy it. Okay, that's helpful to you. So remember that the interval is just saying, what is the lower limit for x? 0. What's the upper limit for x? 5. And if we had a graph going through that, right, we would just look to see, well, what point is at the lower limit? What point is at the upper limit? To find the slope, we just find the slope in between those 2 points. That's all we have to do. That's it. Finding the y-intercept is going to be pretty quick. It's where it crosses the y-axis when you have a graph. When we don't have a graph, the y-intercept, right, happens when we're at, look, 5, 4, 3, 2, 1, 0. The y-intercept is when x is equal to 0. I'm going to go ahead and put that right here. Hey, just to remind me, it's when x is equal to 0. What is the y-intercept? We look, when does x equal to 0? Okay, so that's what we're going to be doing. We're going to look at when y equals 0 for these. Excuse me, when x equals 0 for these. This is a hard area of the page to write on. Let me see if I can just zoom out a bit. All right. So I have my 2 areas here that I'm going to be working on. I'm working on function A, function B, and I'm going to go ahead and write them down here. So y is equal to 1/2 to the x. These are going to be quick, actually, I think. Y is equal to 2 to the x. Okay. I replaced it with y instead of f of x. It's no big deal. That's just function notation. I just changed it to y. It's fine. There's nothing different. We never had to solve for that x or that f. We never had to solve for that g or that x. It just reminds us what we're doing. It's just function notation. This is just x, y, standard. All right. So here's the thing. We need to find, first off, make a table for each of them, because we're going to just plug in some x values to get our y values. Now, the first number we're going to plug in for x is 0, because that's going to give us our y-intercept. Our y-intercepts. I know it's going to give us our y-intercepts because we already looked at a graph, and when x is 0, here's 3, 2, 1, 0, we're on the y-axis. So I know if I plug in 0 for x, I'm going to get my y-intercept. Because when x is 0, when time is 0, you're at the starting point. Okay. Now, plug in 0 here, we get y is equal to 1/2 to the 0. Anything raised to the 0 power is equal to what? Anything raised to the 0 power is 1. 1. 1. So if I plug in 0 here, I can do it real quick just to remind us, because sometimes if you see it, it's more helpful. Anything to the 0 is 1. Boom. All right. Let's look on the right side over here for B. For function B, y is equal to 2 to the x. 2 raised to the 0 power, 2 raised to the 0 power is 1. Anything to the 0 power. It's a weird rule. You'll learn how it works in Math 2. Why? But anything raised to the 0 is 1 as well. So look, my y-intercept for both of these graphs is 1. All right. My y-intercept is 1 for both of them. Now, I want to look back at this one over here. This is just a graph I'm going to use to explain this. Because remember that when x, which is our time values, when x is 5, 4, 3, 2, 1, when x is 0, when time is 0, have you even started yet? When time is 0, have you started yet? When time is 0. Like if you had to take a test, and I said, how much have you gotten done at time is equal to 0? You haven't done anything. It's the start. It's the start, right? So here's the thing. When I have 0 for x, if I get a 1 as my y value, that is also my initial amount because I plugged in 0 for x. I got 1, so I know 1 is my initial amount because it's saying when time is 0, y is equal to 1. When time is 0, my initial amount is 1. Okay. Same over here. This is also the initial amount. So remember at the end we're going to have to say something comparing these two things. So right now I look at this and I'm like, well, let me put them up here too. The y-intercept is 1. The y-intercept is 1. Okay. You know, these are the pieces of information we're going to be comparing. And at this point, I would say, you know, if I was starting to describe it right now, I'd say, well, both functions started with the same initial value of 1. You see? There's nothing different between them. So when they're the same, we can just say that they're the same. They started with an initial value of 1. All right. Now, we know we're looking on this interval between 0 and 5. So if I was doing that over here, 0 and 5, like I said, you would look, if you had a graph, you would just look to where those points are. But here we know that this is at 1, right? That is at 1. So now I already know this point is 0, 1. To find my slope, I just need 2 different points. So this up here is 5 for x. We got to find out what it is for y. All right. I know there are a lot of steps, but let's just go back and remember. All we're looking for are our y-intercept and our slope. Right? So far we did y-intercept. Now we just have to look at slope. So you got to think about it as this is like a problem that has a few different parts to it. But let's just recall that our slope formula is, I'll put it over here, nice and big. Slope is y2 minus y1. That is going to be the rise, the change in your y values. Down here, x2 minus x1. Right? That's side to side. It's a change in your x values. So far, I know it's on this interval, 0, 5. I know at 0 it was 0, 1 because I worked that out already. All we have to do next is plug in 5 for each of these equations to find what goes here. What is the y value there? They're going to be different because these are different functions, but let's just go ahead and put it in here. We're going to look up what 5 gives us. The reason I chose 0, 5 is because they told us what interval to look. Remember? Look here because it was 0, 5 between 0 and 5. That's it. Yeah? So far so good? All right. So let's keep going with this then. We're going to take our function here, which was our second function, or function A and function B. And we're going to take function A and we're going to plug in 5. 1/2 to the 5th. I'm going to do it over here. 2 to the 5th. Calculator work. Go and get your calculator out if you don't have it. I want you to make sure to have it. So when I do it and you watch on my calculator, it's easy. I want you to get the practice while we're doing it. So let's see. We got to go 1/2, 1 divided by 2. Okay. Then we're going to raise it that button right there, raise it to the 5th power. And what do we get? Y is 0.031. That's fine. This is the 1,000th place, guys. It's like if you cut a penny into 10 pieces. We don't need to go next because that's 10,000th. We aren't going to have to compare that detailed. Watch me eat my words, and actually we do need it. No, we don't. I know what this is going to be. All right, so next we have 2. Remember the exponent button up here? Y to the x, or sometimes it's the box to the box, or chevron symbol. So 2 raised to the 5th power, 32. Right. Now, what did we just figure out? We figured out that this one is 0.031. Figured out that this is 32. So look, what I have are these 2 points now, 0, 1, 5, 0.031. Over here I have 0, 1, and 532. So all I have left to do, and I know that probably seems like a lot, I have these 2 points here for A and for B. I need to plug them in here, get our slope for each, and then just compare it as a final. It's like one problem is like 3 problems. I know. Okay, so we have our different points now. This is x1, y1. Doesn't matter what is the 1 and 2 group, as long as you're consistent. So let's do this. This is for function A. Let's do function A first. All right, let's see. We're going to follow this right here. So we're going to go slope is equal to y sub 2. Y sub 2, right here. Right? Y sub 2. You just got to look real close. Make sure you organize it. Minus y sub 1. Let's see, y sub 1 is 1. I like these numbers. So I just plugged in y2, y1 for my first function with these points that I figured out. On the bottom, we have x sub 2, 5, minus x sub 1, 0. All right, that's going to be nice. Let's see. We get 0.031 minus 1 divided by 5. All right, we get negative 0.194. So let's see, let's write it in here. Equals negative 0.194. That's a 4. All right, so I got my piece of information I was looking for there. This is horribly messy, guys. I'm sorry. It's how sometimes where the problem is on the page, I move the page around when I'm writing all this stuff. It's not your fault if it's confusing. This actually kind of goes like this. Yeah. All right, last we're going to do this set of points. So we got to label them x1, y1, x2, y2. All right, we're going to do y sub 2, 32, minus y sub 1, 1. Yeah, it's 31. All right, then we do x sub 2, minus x sub 1. So we're going to end up with 31 over 5. So we end up with 6.2. All right, 6.2. Whew. I'm tired. Not really. I got more. All right, let's look. Finally, we're answering this. It looks like A and B have the same initial amount, the same y-intercepts. So I'd write that. Function, this is like our final answer. A and B have same initial value. That's our y-intercept. Function A and B have the same initial value. I look at that and I could see that function B is 6.2. Function A for the slope is negative 0.194. So if I'm comparing these, I could say different things. I could say this one's decreasing because it's negative. This one's increasing. Or since I'm comparing them, look what I can say. You guys okay with me saying this? Function B's slope is increasing faster than function A. Function B has a greater slope, so it's increasing faster than function A. Look at function A. The slope is negative 0.194. Look at function B. The slope is 6.2. This is more, right? You see how that's just more than that? When we're comparing slope, the greater the number, the faster its rate of change, the faster it's growing. Okay, so you could say function A and B have the same initial value, but function B increases faster. I don't even think we have to say that function A is actually decreasing. We could just say A is going fast, or B is going faster. That is the worst. Take a picture, put this like in the yearbook. Jesus, that's the worst. That's the worst notes I've ever done in my life. I'm sorry. Hopefully the description, the verbal, and the writing is okay. Maybe you're like, my writing's bad too. I can read that better than usual. Okay, I know. This is tricky, right? This is tricky. Now, I am going to be really loose with the deadline for these homeworks. So if you need to work on a little more, if you need to meet with me in one of the morning sessions, just real quick, from 9 to 9:30, I still have Thursday open. So let me know if you want to meet maybe on Thursday to look at it a little more. Okay. But let me just remind you what we did. We saw that we had the interval 0, 5. So that tells us where to look. Where to look. Next, we found the Y-intercept, right? Found the Y-intercept by plugging in x is equal to 0. Yeah. Okay. Angelina, wait, you're not in this class. I'll let you come in anyway. All right. So remember that, hey, Angelina, you're a little bit early, but welcome. Oh, you guys, I'm a little bit late. Whoopsie. Sorry, guys, I'm going to end this quick. We found the Y-intercept by plugging in x is equal to 0. And then, right, we plugged in 0 and 5, which gave us our Y answers to plug in here. Okay, so maybe even screenshot this because this is how we're going to do the problems. I'm going to suggest this. If you wanted to meet with me or go over this further, there's already somebody that wants to do it. So I'm going to say Thursday at 9 a.m. to 9:30. 9 a.m. to 9:30. We'll go over a little more of this, okay? Soonly, can you make that? Melanie, confirm. Yes, okay, you confirmed already. All right, so I'll see Melanie and Soon Lee on Thursday at 9 a.m. If anyone else wants to join, you're welcome to. All right. I'm really sorry this went late, guys. Let me stop this video and